It'll be a supplement to what we did in the previous week with the mushroom exercise. But I'll also introduce some new concepts, such as Boolean operations, blocks, and some useful commands in which help you reorient yourself in your Rhino space. So yeah, I guess I can start now.
Yes.
Yeah, so Boolean operations, what are those? Honestly, I don't know either. No. In simplest terms, they are used to create new forms from existing forms. So Boolean operation procedures fall into, I would say, one of three categories. The first being an addition. So you could have multiple objects, combine them together to create your new object. You can have a subtraction procedure in which think of it like an apple and somebody taking a bite. So you could have one object that's being cut out from another object to create the new form. And the last one I would say is an intersection in which wherever objects overlap is where Rhino determines the new object. So I'll demonstrate to you guys these procedures. So how to find your Boolean operations. If you have your toolbar to the left, they are these two spheres, and you could click this little triangle drop down, and they should be the first four commands available. Or you could go to your solid tab at the top, and it should be at the last section. So you got your union, difference, intersection, Boolean to objects, and Boolean split. Okay, so we'll go through one by one just to show you how it works. So with our Boolean union, we are adding our objects together. So I'm going to type out my command, Boolean union, and Rhino is asking for the surfaces and poly surfaces we want to combine together. So in this case, it doesn't really matter what order we select it, as long as we select all the objects that we want. Press enter, and now I've got my new object, which is a combination of our sphere and our box. And they're combined together now as, let's see, closed solid polysurface. With our Boolean difference now, we have the choice of choosing which one is going to be the object that remains, I guess. So with our Boolean difference, I'm going to type that out. Our first action is to select the objects we want to subtract from. So going with the apple analogy, I'll pretend like this is the apple that we want to take a cutout from. So once we've selected that, press enter, and then our next choice will be to choose the object we want to subtract with. And in this case, it's going to be our green box. And what we'll expect is a cutout of wherever our green box is intersecting with our red sphere. So once I press enter, we'll see that that is the result. And I'm going to undo that and see what result comes from choosing the green box as the object we want to subtract from, and the red sphere is the object we want to cut out with. So let's do the Boolean difference again. This time I'll select the green box first. So we're going to cut out from the green box, press enter, and then we'll choose our red sphere now to cut from the green box. And what's left is this. So if you're having difficulty, sometimes I have difficulty in just setting up my camera properly on an object, and it gets really frustrating like this when I'm rotating around. So a useful command or shortcut is called ZS. So ZS just means zoom and selected. So we'll select our object that we want to zoom and focus on. You could type in ZS, and that should reorient our camera to this object. And you'll notice that in the command prompt, you'll have another similar command called ZSA. So that is just the same command, just applied to all of the viewports. So I'll show you what that looks like. Type Z as A and have our object selected, and now we've got it focused in every viewport. So that's really useful. The next Boolean operation is our intersection. So you could see that we have overlap between the two objects. And so what Rhino will identify with this operation is this, I guess, merger of the two objects, and that'll be our result. So with Boolean intersection, I'm going to the solids tab, using intersection, and this is somewhat order dependent. So if I want to, yeah, I'll show you with the green being selected first, and then our red sphere being selected. The result is our object that is created will remain in the layer that the green object was selected first. So if I did this operation again with the red sphere being selected first, enter, and then selecting our second object, our resulting element will be in the same layer as our first selection, which was the red sphere. So that is somewhat order dependent, but it's easy to change our layers through this layer dropdown. Okay. And with our Boolean split, acts similarly to intersection, except we're not going to be removing any of the original objects. We're going to split it, and that's going to, yeah, basically cut wherever it's being overlapped, our objects. So I'll go to the solids tab, Boolean split, and if I want to split my green object, I'll select that first, and our cutting object will be the sphere. And then you'll notice that a third object has now been created. So we've split, I'm going to hide this for a second. We've split this green object using our red sphere. And if I wanted the other way around, where my red sphere is cut, I'd have to select that first and then choose my green box as the cutting object. Lastly, we have Boolean toObjects, which is limiting our Boolean operation to two objects, very obvious. And what this allows us to do is toggle between these operations, the union, the difference, the intersection, so we can visually see what the results are. So I'll type in Boolean toObjects, select my two objects, and now through clicking, I can cycle through the different options that I can result in. So in this case, I'm Boolean differencing my red sphere with the green box. So I can enter, and that's the result of my Boolean operations. Does anyone have any questions so far? Yeah, just place it in the chat if you're a bit shy, but feel free to interrupt me whenever. Sometimes Boolean operations don't go the way that you want to, and it'll result in a failed operation, meaning there's no, the command is not executed. And in these cases, it's usually one of two reasons, I'd say. The first being that your objects aren't properly intersected with each other. And in order to know if they are properly intersected, you can use the intersect command. So you could type out intersect. And what this will do is once you've selected your objects, doesn't really matter the order, I believe. It'll create a curve that will outline where these two objects are intersected. If your curve is closed, then there shouldn't be a problem. But if it's broken up, that means there needs to be a modification either to how your objects are intersecting with each other, how they overlap, or with the objects themselves. So you might have to do some modifications for both. And I would say the second reason is because the objects that are used in the operations aren't similar or aren't like objects. So even in this case, in my properties panel, where it says type, I have a closed surface, and this is a closed extrusion. So they aren't technically exactly the same object. They still work, but there might be cases where this operation wouldn't be successful. So if you're trying to do a Boolean operation on an open surface and a closed poly surface, that might have some reason in an unsuccessful Boolean. So make sure as much as possible to keep like or similar objects together when doing these operations. Okie dokie, so that's the Boolean operations, basically the gist of it. I'll move on to blocks. So I'm going to reorient myself to this object, typing in ZSA. Bam, we're right there. And so I want to do a little bit of an exercise that incorporate what we just learned, the Boolean operations. And I have myself reference images, a sketch of what I want to do. So here is our mushroom from last week. I want to add some windows to them. And I've created some rough sketches of what the dimensions and this look of the window is. So it's a circular frame. Has a bit of depth and then a little bit of a cutout. So this is in section. And I want to create a row of these on the length of our stem. So a few things that we'll be looking at is how to create this circular frame, what operations we can do to have this result, and then how to apply our window to this really irregular surface. So I chose this surface because it's difficult. We can orient our frame to a planar surface, no problem. It's when we get to something more organic looking like this is where it's nice to have useful commands. So I'll show you these. First things first is to create this frame. So I would say the best way to create this is using two cylinders, one that is the larger cylinder and a smaller cylinder in which we can cut out from our bigger one. So I could type in cylinder in our command prompt, or I could go to solid, and cylinder is our third primitive object. So most of the primitive objects are in our first section. I choose cylinder. So I'm defining my base point at the moment, which is our center, and then my diameter, which I've written as 40 in my sketch. So, oops, do that again. Base point, and I'll type out 40. And then we need our height, which I've written as 10. Okay, so I can type 10 and enter. So I've got my first cylinder. I can draw my second cylinder, which I don't really have dimensions for, so I'll roughly estimate what this opening is. And from the looks of this section, it's about halfway in between, so that should be about 5 units of depth. So I'll type in cylinder, specify my base point, and it'll be easy if you have your snaps on. So what I have is my O snap toggled on, and I have my center checkbox applied, so that when I'm hovering around the perimeter or close to the perimeter, I'll be able to select my center point. And then from there, I'll specify again the dimension. So I'll choose something like 30 and a depth of 5, which in this case, we'll need to apply a negative so that it's inset into our existing cylinder. So I'll type -5, and that looks about right. So I could click or enter again to execute this command. And now what I want to do is Boolean difference this. So I could type in Boolean difference, or I could use my Boolean to objects to toggle through the different options until I get the result that I'd like. So I'll do the latter half just to see what is available. Boolean to objects. So that's not what I want. This is pretty much what I want. Yeah. And enter to execute our command. Now I have the ability to apply this onto the surface using these two useful commands, orient on surface and splop, which is weird sounding, but it's a command. And orient on surface. So orient is a prefix for multiple commands. And basically what that allows me to do is, in any case, in any one of these commands, is to both translate and rotate my object from one location into another location, all in one command. So I could change this placement of my window from this ground plane here onto our stem. So how do we do that? I'll first type in orient on surface, and we'll be creating our base points for this. So I will choose somewhere in the center as our base point. So again, hover near the perimeter, and then center snap should be available. And then I'll choose something from our edge as the second reference point. And so what I've defined is an axis to which we can reorient or redraw onto our surface. So I'll click this surface now, surface to orient on, and a new dialog pops up. Basically, we're able to define the scale, whether it's the same scale or a different one, and the rotation of our object. Right now, I have rigid means or checked. Rigid just means that your form will remain exactly the same from when it was on the ground plane to onto the surface. But if I have it unchecked, that means it has the capacity to deform its shape onto the surface. So I'll show you what that looks like when it's deformed. Again, as in with any other command, there's going to be options that you could choose from within the parentheses. So in your case, you'll probably have copy set to no, but we want to set that to yes. Otherwise, we are literally just taking this frame and moving it onto here instead of creating multiple copies that I want to place along the length of the stem. So I'll set that to yes, and then we could start placing our windows. I think I drew 6. Oops. Maybe I'll unselect some of these so it makes it easier. Yep. Okay, and enter when you're complete. So because I had the rigid checkbox unchecked, you'll see that our form has deformed a little to the shape of the surface. Otherwise, I'll redo the command again. Center checked. And if rigid was checked on, enter, you'll see that it remains exactly the same. And so some of its back surface is not going to be adhered to the surface of the stem, which is up to you when you're doing your models to determine whether that's necessary or not. Okay. Okay. Let's go through the splop command, which is pretty similar as well. I am going to type in splop, and it wants me to determine the center of a reference sphere. So I'll put that center, and then I think anywhere on the perimeter of this shape is fine. And what we've drawn is a sphere, which kind of locates important points of our object that we want to move. So we've defined the center and basically the edge. And what we're going to do is redraw the sphere onto the surface. So that way it can determine how your form is placed onto the surface. So I'll select this back surface, and we're going to redraw the center point and however far the edge is. So something like that. And I could do that again. Okay, and enter. So with this command, you don't have the option to keep your form rigid. You'll see that it's deformed to the surface as well. And with this option, you have more freedom in determining what scale your object will be when it's placed onto the surface. So these are two really useful commands, and they can be applied to any sort of geometry. In this case, I did an irregular surface with kind of shallow curves, but you could put it onto just a planar surface like your wall, and it should work perfectly fine. Okay, and now I want to run through the concept of blocks. So this is fine and dandy, but say I want to make modifications to these windows, I would have to redo my original, which I have on my ground surface, and then reapply the windows into the same location. So that takes a bit of time. What a block does is it saves your object or objects as a definition into a Rhino, and basically it becomes a template. So with these objects or customized object that you've created and turned into a block, you now have it saved into Rhino, and it could be cataloged. So you can delete these objects, but because it's still saved in Rhino, you could reinsert it into your project file. And because it's saved as a definition, you have the potential to update that definition and have it updated with all the copies that are placed into Rhino. So that might be a little bit confusing at the moment. So I'll show you with one that I've already created what that means. So these are a set of boxes, just random boxes, and I've changed them into a block. So when we look into our properties tab and object type, it's now turned into a block. So where can we retrieve these blocks? We can type the insert command. And because I've already set this as a block, it's able to be is placed into our model now. So even though this is now deleted and it's nowhere in our workspace, it's still retrievable because that definition of those 3 boxes have been saved into Rhino, into a catalog, which you can then replace into the workspace. And what I meant by having the definition being updated and having all copies reflect that update. So these technically aren't the 3 boxes. They have the definition of the 3 boxes. So all of these are holding the definition. They're not technically the original 3 boxes. So what I can do is I could double click one of these blocks and enter into the block definition workspace. So now we are able to adjust the definition of this block. And it doesn't matter which one you choose. They're all sort of like vessels that hold this definition, and you can adjust it now. So what I could do is I could delete one of this box, and with this change now applied to this definition, because all of these have the definition applied to it, it should also reflect now only 2 boxes. And again, it doesn't matter which one you choose, because they have all the same definition. They're all going to reflect the same change. And so this becomes useful for our window because we can place them onto our stem, but continually modify it without having the need to modify the original and then replace these objects again. So we'll make this into a block. Right now it's a closed solid poly surface, just keep that in mind. So when we type block, we're determining our block base point. So if you remembered me placing this object into Rhino, there was a point in which I can place it onto. So in this case, it'd be useful to have it in the center. And just keep in mind, whatever object you're creating, try to have it in a place that makes sense. So if you have a door, for example, that you want to make a block, maybe it's not wise to have it outside of the door. Put it on a datum like the corner or the center edge, in which placing it into your model will be very accurate and consistent. So in this case, I want to choose my center. I'll define what the name of it is, and I could give it a description as well, but we'll just keep it as window. I already have one, but I'm going to replace it. So now that I have my window block, I want to delete these and redo basically this operation. So orient on surface, I'm selecting one reference point, and then the second point as our scaling factor. We'll select our surface, and then uncheck this so it's not rigid, okay? And then we could place our object. Whatever. Okay, what you'll notice is, though, with this block instance, that even though I've unchecked the rigid option, so it should deform, because it's a block, it won't. Blocks are limited to scaling and rotation operations. So unfortunately, if you are wanting your block to deform to the surface, you'll have to explode it, meaning you're taking it away from the definition and it's back to the same object it was before, in order for that object to deform. So that's one of the limitations with the block. But now that we have our block objects applied to our stem, I could go back to this copy or this instance. And because it's on a surface, it's a lot easier to change than it is on an irregular surface like that. So I can double click it again to enter its work mode. So I'm now redefining the definition of this block and say, I want like a center thing here. So I could type line, doesn't really matter at this point, and give this line some thickness. So from our last tutorial, I showed you the pipe command. So I'm giving this a radius, circular radius of 1. I'll move it so that it's somewhat intersecting with this object. Again, my thing is like moving whack. So I'm going to type the ZS command to focus it again. And now I want only this portion of this rod to remain. So I think I'll use the Boolean split command and then the Boolean union operation to combine the two. So Boolean split, I'm selecting the object I want to split first. So it's this pipe, and I'm pressing enter, and then the new selection is the cutting object, which is our frame. And now our pipe has been split into several segments. I want to remove the ones that I don't find necessary. So I'm selecting left to right, and whatever's within this continuous line border will be selected. So it has to be fully inside the border for it to be selected. And now that I have my desired object, I can union these two. So I could type Boolean union, or I could go to my solids menu and choose the union option. And now that's one object. I'll delete this construction line. And now I'm happy with the changes made to my definition. So nothing seems to have changed, but because we have multiple copies of this definition, this should also be reflected now with the objects that have now been placed or already been placed on our stem. So this is a useful way to sort of streamline your design workflow, I guess, design workflow, because if you have the intention or already know where your placement of certain objects are, but aren't really exactly sure what your object's final form will be, then this will kind of expedite the process because you're already doing an operation in which you're happy with, so the placement of these windows, and you can continually modify this definition so that they become updated when necessary. Does anybody have questions on blocks? So I did another tutorial solely on blocks, which is available on the Google Sheets link. That Google Sheets link to the tutorials. So you could watch one of those videos in order to have more of a understanding on the usefulness of blocks and how to further organize them. So I'll send that link later in an email. And lastly, what did I want to speak about? Yeah, so we learned last week about bringing reference images in. And these are JPEGs, so you'll see that I have my content, which is drawn on paper, and my background is white. But something useful is bringing in PNGs, which have transparent backgrounds. And I say they're useful because sometimes you'll want to show your prof kind of like a rendering or a 3D visualization of your project, but maybe you don't have time to actually render it in Photoshop. So a quick way is to use the picture command again, like we did with these reference images, and find a PNG of like a person or a tree. And this will be useful now as a scale, but also providing a little bit of context to your model. So in this case, I'm gonna select the vertical. And now this person that I have, I should scale properly to whatever height they should be. But now they're like a little bit of a character that you could put into your model and have like screenshots of them with like as contextual, um, yeah, context to show what the scale of this tree actually is. Because otherwise, maybe a person's actually this tall and not a tiny little thing. So you're not limited to people. You can do these with trees as well. These are very useful, and they don't take a lot of file space. So your files are still kept light. Because I see people, they use model objects, and that's nice and everything, but it does take a lot. It just adds or bloats to your project file. So what I've done here is just use my gumball tool to rotate this 90 degrees. I used this quarter circle and held Alt, or I guess Option on Mac, and that allows you to create a copy, and you'll know there's a copy because you have that white square next to your arrow. And yeah, it pretty much acts like a model, but they're all just reference pictures that you could use. And I think one more thing that I wanted to mention is having a background image. So if you're composing a scene, it's useful to have background image. So with nothing selected, just within a viewport, in your properties tab, you have a wallpaper section at the bottom. Right now, I don't have anything inside. So I'm going to select an image from within my Windows Explorer, and I have this one already prepared. And now you have a background image to which you can rotate your model and adjust it so that it looks to be within the scene. So that's really useful. You could toggle it on and off. You can have it grayed out so it doesn't impede with the visual graphics of your model. So these are all useful. And like we did with our reference images, you can have that image that we placed into the background just as its own surface. So that's pretty useful. Oh, I'm getting a lot of chats. Okay.
So can you show the wallpaper again?
Yeah. So what I did, I don't have anything selected, so I'm just in a viewport, and I'm in my properties tab. There's a section called wallpaper at the bottom, which you can retrieve a file from your computer. So I have my background image here, selected it, and I'll check these boxes so that they're visible. So if you're in a quick rush to show your prof some context to your model without having to render it, this is a good alternative. And I found my people on these websites. So these have all cutouts of people as PNGs, so you could download them really easily. This one's called Skull Gabar. Sounds very Nordic. I don't know my geography. And then this one's called Non-Scandinavia, which also has a diverse range of people cutouts, but also silhouettes. So these are all really useful to download, start developing your library so that you don't have to be depending on your internet when it comes to retrieving these.
Could you enter another person? They're asking how you entered the tree and the
Oh
person.
yeah, I'll do that again.
Thanks.
So I'll hide my background. So this is the picture command. It's the same command we used to get our reference images from last week. So I'll type picture, and it should be one of these supported files, so JPEG or PNG. In this case, we want a PNG because PNGs have transparent backgrounds. So where's my person? Right there. Although we are going to have that white background as the in the preview, it'll disappear when we insert it into Rhino. And I just selected the vertical command so that our reference image is upright. And from there, you're choosing the scale to which your person is going to be placed into. All right, does anyone have any other questions? Yeah, so, and with the tree, same procedure. I've inserted the PNG as a picture, and I'm giving it a little bit of dimension by making a copy that's 90 degrees. So you could do that with your gumball tool on. So you could choose gumball, and with this little blue quarter circle grip, you can rotate. But if you want to make a copy, hold Alt while you're making that click selection. And so now I've made a copy of my tree. Now it kind of looks like, yeah, it looks like mall. I don't know.
Hey, Eric, I've noticed in SketchUp, for example, in 3D Warehouse, sometimes you can pull in, say, a tree like this. And when you first pull it in, it looks like it's just a flat image, but it dynamically reorients every time you rotate your view so that it's always facing you. Do you know if there's any way to do that to these objects in Rhino?
I don't know, but I don't think so. In Rhino, basically, you're determining like the scales and dimensions and angles to which your model is placed into it. So this is considered a model object. And so it shouldn't reorient to where your camera is facing. So that's one of the drawbacks. You'll have to manually adjust this in case you want to have it seen at a specific angle. So yeah, our person here is really thin, so I can't see them at this angle. What is the name of the, okay, so the website,